So anyway, yesterday we have seen, so how to perform mathematical operations on arrays, right? So that is nothing but so all these operators are there. So there are some operators like plus, minus, and star, slash, and slash slash, percentage, and one more is a star star. So these are some of the arithmetic operators. So which we are trying to do it. Okay, right? So these are not attributes. These are functions. Yeah. So all these are the functions. So what these are functions. Okay. These are not attributes here. Did I said attributes? Attributes means it belongs to the object. But are you said object? Module name dot function name. Did I said attributes? These are attributes or functions. These are attributes or functions. Yes, these are functions, not attributes, right? And instead, these are attributes. You are calling the function. NP is what? Module. Add is a function. You can do it. You can use the operator and you can also use a function. Yes. So what we are talking about is aggregate functions here. So in aggregate function, you have a lot of functions, but here I've written some of the functions belongs to the NumPy. Okay, some of the functions belongs to the NumPy here, not all the functions. Some of the functions. See here. Now let me tell you. So these are the functions. So what all these are is, see here. So I'm writing import. So import NumPy as NP. So here I create an array. So those are magic methods. Suppose I'm creating a single dimensional array, np.array. So this is an array having 5 elements. Okay, there is another array, np.array, and this is also having 5 elements. Okay, now I'm writing here C equal to np.sub. np.sub, I'm writing A comma B. Okay. I said A comma B. So it is saying subtract. So what is the name of this is subtract here. So NP dot subtract. So what you are writing A comma B. So it is a function. Now you are writing A comma B comma what is that? C. Now this is subtract. Did I say? I mean sub means what is the name of the function is subtract. The function name is a subtract. Now 1 minus 10 is minus 9. 2 minus 20 is minus 18. 3 minus 30 is minus 27. 4 minus 40 is minus 36. And 5 minus 50 is what here? Minus 45. Okay, right? So in the same way, now you are trying to use, yeah, this is a function name. What is the name of the function is here? Subtract. Okay, so in the place of subtract, you can also use, what is that? You can use minus operator. In the place of that, you can also use minus operator. So after that, I said multiply. So multiply A comma B. So multiply A comma B. I run this. Sorry, I have not. I run this. 1 into 10 is what here? 10. And 2 into 20 is what here? 40. 3 into 30 is a 90. 4 into 40 is 160. 5 into 50 is what? 250. So what is the name of the function? Multiply. In the place of multiply, you can also use what? Star. In the place of multiply, you can also use what? Star. E equal to NP dot. I'll say here floor division. So floor division, some A comma B. So floor division. So floor division A comma, sorry. So floor division A comma B, I said like this. Floor division I've used. Floor division, floor. Integer division, yes. Floor division. So floor division. So function name is floor division, sorry. I think some mistake I'm doing here. Floor division. So the function name is a floor division. So floor division. Floor division. See, divide. So what is the name of the function is floor divide, right? So floor divide. And here I'm using A comma B. So what will happen in this case? Now it is gets a floor division means integer division. Okay, so the result is what here? 0. 1 by 10, 2 by 20, 3 by 30, 4 by 40, and 5 by 50. So F is NP dot float division. So float division is there. So there is a floor division. Now this is float, I think. Division. This function's little bit confusion here. Okay. So division. Float underscore divide. Division. So these functions are some little bit confusion because there are a lot of functions, right? Now this is floor division and there is a function called float division. So float division, for that you can use directly which one? Divide. Yes, directly you can use what? Divide. So this divide belongs to which division? Float division. So directly you can use divide. Okay, 0.1, 0.1 like that. Okay, right. So the function names you have to remember, otherwise you can use the operators. Subtract, multiply, floor, divide. and there is a divide. And yes, so NP dot. So let me talk about mod. So there is a NumPy. So NumPy mod. So mod operation. So mod function, you can use it. So what is the name of the function is mod. So this will give element wise reminder, right? So mod A comma B. So this gets a reminder. If I'm writing E, now you can see the reminders 1, 2, 3, 4, 5. So yeah. So what is the name of the function? Subtract. What is the name of the function? Multiply. What is the name of the function? Floor divide. What is the name of the function? Divide. What is the name of the function? Mod. And NP dot, now I think exponent. Exponent, so B comma A. So this is exponent. So what is the name of the function is? Exponent function. So you are trying to use a function with the name called which one? EXP. What I have written EXP. EXP is what here? Exponent. So print F, yes. So what are the values is? So cannot cast exponent output from data type float to integer. So I said A comma B. We'll just write this exponential. So what is the name of the function is power of. So that is nothing but numpy dot. So what is the name of that is power. So this difference names you have to understand this. I said power. So this is given like this. So one like this. Power this is. So A to the power of B or B to the power of what here? A. So 10, 400. Yes, this is what function called power. So all these are different functions, right? See, what will happen is all these functions, these are functions or these are operators. See, Python provide multiple approaches for solving a given problem. So it is not one approach. It provides multiple approaches for solving a given problem. So now you can do the same operation by using operator also. But what is the difference between operator and function? See, what is the difference between operator and function? Is it operator is a method and this is one individual function. So same thing it is done by using multiple approaches. Okay. So in the place of function, you can also use which one? Operator. But operator is a symbol. So symbols can be remembered easily than which names? Function name. When operator and function is both are same, then you refer it by using what names? Operator names. So these are mathematical operations of a NumPy. NumPy which one? Array. Yesterday I said with operators, but these are with what here? Functions. So that is nothing but subtract, and there is a function multiply. There is a function called floor divide, and there is a function called divide. There is a function called mod, and there is a function called power. So what is the difference between this operator and see here? If I am writing some C equal to A dot, I can use a method here. What I'm using here, add. So A dot add B. I said A dot add B. Now this is which method? Actually, this is called what? Magic method. So magic method. So every operator is having equivalent which method? Magic method. So I can call this by using an operator called plus also. I can call this by using an operator called what? Plus also. Plus and add both are same or different? Same. So for every operator, there is equivalent what here? Method. And that method you call it as which method? Magic method. So you can perform this mathematical operations. You can perform this mathematical operations either using functions or you can do it by using which one? Operators. And when it comes to this aggregate operations, now you have a lot of functions here. There is a function called sum, maximum. Yeah, this is clear. Okay, so you can use operators or you can also use what? Functions. You can use operators. You can also use what? Functions. Now, when you're talking about aggregate operations or aggregate functions, there is a function called sum. For example, I am creating one list. List is there. So I want to add all the elements of list. So what will I do? I'll use a function called sum of A. So sum function is there or not? Yes. So that will add all the elements of the list. In the same way, I'm writing a B equal to np dot array. np dot array 100, 200, 300, 400, 500. Can I use a function called sum again? I'm writing here function sum of B. I said sum of B and I print sum. When I say sum of B and print sum, now this sum function also done sum. A sum function also what here done? Some are not? Yes. But what will happen? For example, what will happen if my array is np dot array? np dot array, I'm taking an array of 2D. So 3 comma 4. Now this is which array? 2D array. I'm writing here sum of C. So what will happen if I say sum of C? So print, sorry, I print here C S value. Print S value. I print S value. So what it is done? Now 1 plus 3 is a 4 and 2 plus 4 is what here? 6. But you also have a function called which one? Sum. But in the place of sum, why you are using np dot sum? Because sum also doing the same thing, right? Sum also doing the same thing. Then why I'm using np dot sum and here I'm using C. So because this will do the operation by converting into flatten array. See here, sum is what it is written here. What it is written? One array is written or not? Yes. So one array is written. Sum is written one array. 1 plus 3. 1 plus 3 is a 4. Now 2 plus 4 is what? 6. But what this sum is doing? What this sum is doing? It is converting your 2D array into what? 1D array and adding all the elements. It is converting 2D array into what? 1D array. Now difference is there or not? So this sum is different than this sum, right? So what this sum is doing, it is trying to convert. What this sum is doing, it is converting this 1D array, 2D array into what? 1D array and add all the values. That is 1 plus 2 plus 3 plus 4. 1 plus 2 plus 1 plus 2 plus 3 plus 4. And what is the result of this is 10. So this is doing aggregate operation, but this is adding. What it is adding? When you're writing here sum of C, what it is adding? What it is adding? So it is written one more array or not? Yes. With 1 plus 3 is a 4 and 2 plus 4 is what? 6.
So this is different than this. But is it this both are same or different? Different. But you want to do some aggregate operation. Okay, you want to do some aggregate operation by adding all the values. Means you are converting the array into 1D array and you are adding all the elements. For that, you are using a function called which one? Sum. So here you have a array and access is there and data type and there is out and there is a keep dimensions and there is initial value and there is where and here no value like that. But in this yesterday I said about a and one more is what initial value and even there is access. Access none are integer or tuple of integers and it is optional. Access or access along which a sum is performed. The default access is what here? None. Will sum all of the elements of your input array. If access is negative, it counts from the last to first access. If access is tuple of integers, a sum is performed on all the accesses specified in the tuples instead of a single access or all the access as before. Now you can define, yes, you can define access. Access 0 is nothing but what here? Column. Access 1 is nothing but what here? Row. Access 0 is nothing but what here? Column. Access 0 is nothing but a column and access 1 is nothing but what here? Row. You can just give. If you write only sum, it is add all the elements of what? Array. If you write A access 0 means it is doing the sum of columns. 1 plus 4 plus, sorry, 1 plus 4 plus 7 plus 10. What is the value is 22. 2 plus 5 plus 8 plus 11. What is the value is 26. 3 plus 6 plus 9 plus 12. What is the value is 30. So that is access 0. And if you are writing access 1, it is doing the sum of which elements? A row. 1 plus 2 plus 3, which is 6. 4 plus 5 plus 6, which is 15. And 7 plus 8 plus 9, which is 24. And 10 plus 11 plus 12, which is what? 33. So you can also define multiple accesses by writing in, tuples. For example, you have a sales. Okay, for example, you have a sales of np dot array. You have a sales of, okay, these are the sales of, so these are the sales of 3 salespersons, 3 months sales. Okay, 3 salespersons, 3 months sales. Okay, 3 months sales, 3 salespersons are there and 3 months sales are there. Okay, so it is like this. So it is like this. Okay. So like this, I've taken the sales. So this is called as a sales here. Now when you print a sales, now this is 3 salespersons, 3 months sales. Now I want to find the sales, sum of sales according to salespersons. I want the sum of sales of salesperson 1. I want the sum of sales of salesperson 2. I want the sum of salesperson 2. Or I want the total sales done by all the salespersons. I want the total sales of all the salespersons. Then I'll say total sales equal to numpy dot sum. Then I'll say what here? Sales. Now will it add all these sales or not? Yes. That is the total sales. That is what here? Total sales. This is the total underscore what here? Sales. Now this returns the total sales. But I want the sales according to salespersons. total sales according to what here? Sales persons. Then what do you do it? So total sales person means according to the person means first person's total sales, second person's total sales, third person total sales. Then you have to use NP dot sum. I'm using a sales, comma, access. You have to give access is what here? 1. 1 means what? Rows. So each row represent one salesperson. Each row represent one salesperson. Okay, total sales. This is a total sales person wise. Total sales person wise. Now here I'm writing a total sales. You can use, sorry, you can use a for loop. You can use a for loop. Now this is, so 10,000, 20,000 and 30,000. So what is the value here? 60,000, 45,000, 15,000, 25,000. This is a value. 50,000, 45,000, 35,000, and this is a value. Now you want total sales month wise. Okay, you want total sales month wise. Means first month total sales of 3 persons. Second month total sales of 3 persons. Third person total sales of what? 3 persons. Okay. So total sales. Okay, total sales what here? Month wise. Okay, NP dot sum. I'm writing a sales and I write here access. Access equal to what here? 0. Access 0 is nothing but columns are not? Yes. So this is the first month sales. And this is the second month sales. And this is the third month sales. Now you are trying to say print total sales. Total sales. And here I'm writing a month. So now you can see first month total sales and second month total sales and third month total sales. That is what access 1 and one more is what? Access 0. There is an access 1 and there is a access 0. Access 1 means row and access 0 is what? Column. Access 1 is row and access 0 is what? Column, right? For example, you have a like this. Now this is where it is access is helpful. This is where access is helpful. You can also have a 3D array. Okay, 3D array which contain access 0 and access 1 and access 2. Access 0 and access 1 and access 2, right? So when you are working with which array? 3D array. Now what is this 3D array? I take a 3D array here. So which contain number of matrices. Okay, assume that there is a sales. There is a sales numpy dot. I'm writing here array. I'm creating a 3D array. I'm creating what here 3D array. 3D array where I want to represent sales of 2 years. 2 years, 2 years, 3 persons, 3 months sales. Okay, 2 years. Okay, 2 years, 3 persons, 3 months sales. 2 years means I create how many matrices? 2 matrices I'll create. So this is 2 matrices I create. And inside this, I need to represent. Inside this, I need to represent sales of how many persons? 3 persons. 3 persons and 3 months sales. 2 years, 3 months, 3 persons, 3 persons, 3 months sales. Okay. How many years? 2 years. 2 years is like a cluster which contain how many matrices? 2 matrices, and each matrix contain how many rows? 3 rows. And how many columns? 3 columns, like that. Okay. Now I take the same thing here. Now this is one matrix. This is one matrix here. Here I write. This is one matrix. And I need to take another matrix here. So this is one more matrix, but I'll try to do some changes here. Okay, some values I'm trying to change here. So like this, these are different cells. So like this I've taken here. Now this is my array, but this is which array? This is 3D array. Now if I print the cells, you can see the cells. Now this is nothing but how many matrices are there? Two matrices. Two matrices means each matrix represent one year. Each matrix represent one year, and each year how many salespersons are there? Three salespersons. And how many months sales? 3 months sales. I want a total 2 years sales. I want total 2 years sales. Total sales. If I'm writing total sales, what should I write? NP dot sum. Just write what here? Sales. Here I don't define the axis. Then what will happen? It will try to add all the values or not? Yes. It will try to add all the values. Now print. So print format, what I'm writing here, total sales. Total sales. I'm trying to write total sales here. Now this you can call it as a total sales. Means it is add all the year sales. Okay, now I want the sales year wise. Tell me, I want the sales year wise sales. Year wise what year? Sales. Year wise sales I want it. Tell me, NP dot sum. What should I write here? Sales. Year wise. I want the sales how? Year wise sales means this is the first year and this is what? Second year. See, this matrix is the first year and this matrix is what year? Second year. So I want year wise sales. I want year wise sales. Year wise sales means now when you see this dimension, okay, just to see this shape of this matrix, you'll be getting it. Now suppose what is this here? Sales dot n dimension and sales dot what is that here? Shape. Now if you see the shape of this matrix, now you have a two matrices and 3 rows and how many columns here? 3 columns. 3 rows and how many columns here? Yes. So it means what is this 2 here? 2 matrices. 2 is nothing but 2 matrices. Means this is, say this is nothing but 0. Or this matrix is nothing but what? 0 and this matrix is what here? 1. This matrix is 0 and this matrix is what here? 1. This is nothing but axis 0 or axis 1. Axis 1. Axis 0 or axis 1. Axis 0 or axis 1. See here, this is a matrix. They go here. Now this is nothing but how many rows? How many rows are there here? 2 rows. And each row is one matrix which contains 3 rows and 3 columns like that. Okay. Now I'm writing here, see here. So total sales year wise. Total sales year wise, I'm writing NP dot sum. NP dot sum sales. NP dot sum sales, and here I'm writing axis. What is the axis I'm using here? 1. Axis 1 I'm using just to see here. What will happen? So here I'm writing total sales. Total sales, how it is year wise. So total sales underscore what is that year. So if you run this, no, but I said access one, right? Access one means row na column. Actually, access one is a row or column? Row. So row means how many rows here? It is taken 1,23,000 and 1,23,600. 1 lakh is 62,000. This is how it is displayed. How it is displayed? Access one is nothing but a row or column? Row. Access one is nothing but a row. Row. It is a row. Row means what is a 1,23,000 is there? 1,23,000 means here 10,000 plus 20,000 plus which one? That see, is it adding all these values or is it adding each row? It is adding each row. This is 10,000 plus 20,000 plus 30,000. What is the value? What is the value? 60,000. 60,000 plus 60,000 plus what it is adding now? Bolo yaar, 60,000 plus what it is adding? 15,000. 15,000 plus 20,600 plus 39,000. Is it value is 1,23,000? Yes or no? So it is adding what it is adding? Rows or columns? Rows. It is adding which one? Rows. It is adding a rows. This is a rows. It is adding all the rows. This is adding all the rows, right? So that is what here access 1. Suppose if I am writing access 0, I write here access 0. What is access 0? It is adding which one? Columns. Access 0 means it is adding what? Columns. Now what is the value it is given? What is the value it is given? The value is given is 1,10,000. But how it is given? 1,10,000, right? So access 0 is there, access 1. See, don't be confused here. If I'm not writing anything, what it will do? It will add all the sales. If I'm not giving anything, it is adding all the sales. It is adding all the sales, right? Now, what is the total sales is? 6,83,000 what? 600. Okay. Now, when you are talking about 3D array, it is having number of accesses. So just to see a representation, I just show you representation. 3D array. Now you have an access 0. You can see this here. Access 0 is there. Just to see this one. There is access 0 and access 1 and there is access 2. So there are 3 accesses. I just wanted to show you the picture here. So this is a 3-dimensional array. Okay. You can see this is what here? Access 0. And this is what here? Access 1. And this is what here? Access 2. So there is an access 0 and access 1 and access 2. What is access 0 represents here? See, there are 3 accesses, right? Access 0. This is access 0. This is access 0 and this is access 1 and this is what here? Access 2. It means if I'm writing here, suppose if there is a 3D array, if I'm writing some A of 0, if I'm writing A of 0, then what will happen? If I'm saying A of 0, what will happen? I'll get the first matrix or not? Yes. If I'm writing A of 0, 1, if I'm writing A of 0, 1, or if I'm writing A of 1, A of 1, A of 0 means first matrix, A of 1 means second matrix. A of 0 is first matrix and A of 1 is a second matrix. See, there is no confusion. This is called access 0 and this is called access 1. This is called access. So how many indexes I should use? How many indexes I should use? 3 indexes. How many indexes I should use? 3 indexes. Now here access 0 represents what? Matrices. Access 0 indicates what here? Matrices. Access 0 is a matrix. Just remember this. Axis 0 is nothing but matrices. How many matrices are there? Two matrices are there. How many matrices are there? Two. Uh, there should not be any confusion here. Okay, what will I do is just to try to take this matrix here. I'm just taking this matrix. This matrix I'm taking it. Okay. Now this is a sales of one person or not? Tell me, this is sales of 1 year. Sorry, this is sales of 1 year. So here I'm writing year. So year one sales. I'm writing NP dot array. NP dot array. Now this is because sum should not be confused in sum, right? Because of that, I'm taking individually. Because of that, I'm taking what? Individually. This is year one sales. Now tell me, if I'm writing year one sum, year one sum equal to NP dot sum. What is this here? Year one. This is just to know what are the values I'll get it. Because when you do the sum, you should know it. When you do the sum, you should know it. When you do the sum, you should know what is the sum is. Comma. Okay, now when you do the sum, you should know what is exactly. What happened here? Oh, comma. So these are the values. Okay, now see here. Now this is a sum. I said here year one. Now year one sum is what? 2,75,000. Okay, this is a sum of year one. Okay. Then here I'm saying year one sum. I want month wise. I want month wise. Then I'm saying NP dot sum. NP dot sum year one comma. What is this here? Access. Access is what? 1. So access 0 month wise, right? Column access 0, and here I'm saying year 1 sum underscore what is that? Month. So this will give the sum. How? Month wise. Now this is 1,05,000, 80,000, and what is that? 90,000. So this is nothing but 15,000 plus 48,000 plus what is that? 60,000. What is the value is like this? Okay, right? Now that is nothing but year one sum month wise. Year one sum month wise. Year one sum person wise. If it is a person wise, you will say NP dot sum. This is a year one, and I'm writing here access. What is this here? Access one. Access one is nothing but row wise. Access one is what here? Row wise. So year one sum. Then I'm saying here what? Person. Person wise sum, you'll get it. What is a person wise sum? 60,000 is nothing but what is the value is 10,000 plus 20,000 plus what? 30,000. What is the value you get? 60,000. Okay. Then 45,000 plus 50,000 plus 25,000. What is the value you get? 80,000. Sorry, 85,000. Like this. So this is first year. But when it comes to the 2D array, how many years are there? When it comes to the 2D array, how many years are there? 2 years. How many years are there? 2 years. And each year is having how many months? 3 months. And how many persons are there? 3 persons. How many persons are there? 3 persons are there. Okay, 3 persons are there. Just to see here. This is my array. Okay, now there is a 2 years. This is a first year and this is what? Second year. This is a first year. This is a first year and this is what year? Second year. Okay, 2 year sales are there. Now I want sales. I want sales according to which one? I want sales according to which one? Year wise. Means I want the total sales of first year. I want the total sales of which one? Second year. total sales of first year and what? Second year. Okay. Then what I'm doing is I'm writing like this. Now just to see it. Again, I'm taking this. See, axis you should remember. Axis, what axis represents? Dimension, right? What axis represents here? Dimension. Now this is 3D array. This is axis 0 and this is axis 1 and this is what here? Axis 2. Axis 0, axis 1 and what is that? Axis 2. What I am doing is here. There is a I, there is a J and there is what here? K. So I is there. I. If I am writing A of 0, this is 0 and this is 1. This is what here? 2. If I am saying J, J is nothing but what here? J is nothing but what here? Yes. K is nothing but each matrix. Yes. So columns. Now just remember this. Let me tell you this. There is no confusion, right? There is no confusion here. If you see this is a shape, right? What is the shape is? ND array. What is the shape is? 3, 4, 2. Okay, 3, 4, 2. What you see here, it is what? Axis 0. This is nothing but axis 0. And this is nothing but what? Axis 1. And this is nothing but what? Axis 2. If you are writing A of 0, 0, 0, A of 0, 0, 0, what is this 0 indicates? What is this 0 indicates? This 0 indicates what? Row or column? This 0 indicates here row or column? Column, right? Column or row? See, this is matrix. This is a matrix, 3D matrix. Now this axis 0, first 0 indicates what? Row or column? This is indicates what? Column. And this is 0. This 0 indicates a row. And this 1 indicates, this 0 indicates what? Column. See, it is just like a number of matrices. Number of matrices within the matrix. Okay, if you are seeing one by one, then we'll say one picture is there here. I think so. This is 1D array anyway, axis 0, and this is axis 0, and this is what here? Axis 1. You will say 0, 0, 0, 0, 1, 0, 2, and this is what here? Axis 0, and this is axis 1, and this is what here? Axis 2. Axis 0, axis 1, and axis 2. Number of matrices. Now it is represented like this. This is nothing but axis 0. So this you can call it as axis 0 and this is axis 1 and this is what here? Axis 2. Means if I'm writing 0, 0 means it represent which matrix? 0 means it represent which matrix? First matrix. If I'm writing here 1, it represent which matrix? Second matrix. If I'm saying a 2, it is represent which matrix? Third matrix. And then if I'm writing again 0, this is represent which matrix? First matrix or not? Yes. First matrix, which row? First row. This represent first matrix, which column? First column. That is 0, 0, 0. 0, 0, 0, 0, 0, 1, 0, 0, 2. Yes. This is called as axis 0, axis 1, and this is what? Axis 2. Axis 0, axis 1, and what? Axis 2. Axis 0, axis 1, and axis 2. No confusion here. So there is no confusion. This is how it is been read. Axis 0, axis 1, and axis 2. So that is how you read it. See here. This is axis 0, axis 1, and axis 2, where you have to use multiple indexes. Now, this array is very big. We'll reduce the number of values so that manipulating becomes very easy. We'll reduce number of values. because you'll have some confusion, right? So np dot array, I create with 1 comma 2. I create with 1 comma 2 comma 3 comma 4. 1 comma 2 comma 3 comma 4. So that you can understand easily. So there is a 10 comma or again I'm taking some 5 comma 6, 5 comma 6 comma 7 comma 8. Not big one because manipulating should be easy, right? Now this is having number of matrices. How many are there? 2 are there. Then what you are doing is you are writing S. Listen here. There's no confusion here. There is S. S is nothing but sum. No confusion. I'm taking simple elements. NP dot sum. NP dot sum A comma. If I'm writing only A, so what it is doing? It is adding all the values. All the values are added. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus what? 8. 7 plus 8. Now how this matrix is? So how many matrices are there here? This is first matrix. Having how many rows and how many columns? 2 rows and 2 columns. Here I'm just drawing it. So this is 1, 2, 3, 4. This is second matrix. This is the second matrix having how many rows and how many columns? 2 rows and 2 columns. 5, 6, 7, 8. 5, 6, 7, 8. Okay, right? Now this is clear. This is called which one? This point is which one? Axis. This is axis 0. This is nothing but axis 0. This is what here? Axis 1. This is axis 1. And this is nothing but what here? Axis 2. This is axis 0. This is axis 1. And this is what? Axis 2. Clear? Okay, na? This is axis 0. This is axis 1. And this is what? Axis 2. Axis 0, axis 1 and axis 2, right? Now what I am doing is S2 equal to NP dot sum A. Then I am writing here axis. What is the axis I have given? 0. Axis 0. When I say axis 0 and S2, now see here what is the sum is given. It is given sum as 1 matrix which contains 6 comma 8, 10 comma what is that? 12. 6 comma 8. Now see here, sum, what is the name of the matrix? What is the name of the array is A. This is 3D array. And what is the axis I have given? 0. What is the axis I have given? 0. Axis 0. I said what here? Axis 0. It is written. It is written one matrix with how many rows? 2 rows and 2 columns. What is the value of this is 6. What is the value of this is 8. What is the value of this is 10. What is the value of this is 12. Now what is a 6? How you get a 6? How you get a 6? 1 plus 1 plus 1 plus what here? 1 plus 1 plus 5. 1 plus 5 is what here? 6. 1 plus 5 is a 6, right? So 1 plus 5 is a 6. This is column, right? This is a first matrix. What it contain? There you are, simple. First matrix, what it contain? 1, 2, 3, 4. This is a second. What is the second matrix contain? 5. What it is having? 5, 6, 7, 8. 5, 6, 7, 8. What I said here, axis? What I said here, axis? 0. Then what it is done? 1 plus what? 5. 1 plus 5 is what here? 6. Getting or not? 1 plus 5 is what here? 6. 1 plus 5 is a 6. Okay. Then next is what? 6 plus 2 is what here? 8. 6 plus 2 is a 8, and 3 plus 7 is a 10, and 4 plus 12, 4 plus 8 is what here? 12. Column. Yes or no? That is what axis. What is that axis is? 0. That is axis 0. Two matrices are there. Now I am writing S3 equal to NP dot. This is clearer. Axis 0 is clearer, right? So what you are doing? You are adding. Yes, this is, assume that this is nothing but two matrices. Two matrices. This is axis 0. This is 1, 2, and this is 3, 4, and this is 5, 6, and this is what? 7, 8. Now this is axis 0. What it is doing? 1 plus what? 5. What is the next one is? 6 plus what here? Sorry, 2 plus 6. Then 7 plus 3. Next is what? 8 plus 4. Now it is adding these cells. I mean, it is adding these elements. It is adding these elements. That is what here? Axis 0. Then next I am saying A comma, what is this? Axis, axis what here? 1. So print S3. Print S3. What is S3 is now? 4, 6, 12 and what? 14. 4, 6 and 12 and 14. So this is the result. 4, 6, 12 and 14. Now there are two matrices. So this is a matrix 1. What it is having? What it is having? 1, 2, 3, 4. What is the next matrix? What is the next matrix? 5, 6, 5, 6, 7, 8. Now what it is doing? Sorry. 5, 6, 7, 8. What it is doing? It is adding 4, 6. 4, 6 means 1 plus 3 is what here? 4. 2 plus 4 is what here? 6. Okay, then next one is what? Now, what is the next one? 12, right? 12 means what it is adding? 5 plus what is that? 7. 5 plus 7 is what? 12. Then next is 4 plus 8 is what? 4 plus, sorry. 6 plus 8 is what here? 14. 6 plus 8 is what here? 14. Right? Yes, that is what here axis. That is what here axis 1. Axis 0, axis 1. Then one more is there. What in axis 1 is doing? Axis 1 is column wise. Axis 1 is row or column? Row. Axis 1 is a row. Axis 1 is what? Row. Row, na? Yes. What is the value? What is the value here? 1 plus 2 is what? 4. This is the first row. 3 plus 4 is what? 3, sorry. 1 plus 3 is what? 4. And 2 plus 4 is what? 6. 2 plus 4 is a 6. Then next is 5 plus 7. 5 plus 7 is what? Sorry. 5 plus 7 is what? 12. And then next is 6 plus 8 is what? 6 plus 8 is 14. Then next is S4. S4 equal to NP dot sum A comma. What is this here? Axis 2. Acid axis 2 comma S4. There is an axis 2 here. What is the sum is? 3, 7, 11 and what? 15. 3 means 3, 1 plus 2 is what? 3. And 3 plus 4 is what? 7. 5 plus 6 is 5 plus 6 is what? 11. And then 7 plus 8 is yes, 15. Right? So what is axis 0 now? In this case, axis 0 is what? Axis 0 is a row. Axis 1 is a column. Sorry. Axis 0 is a column. Axis 1 is a row. Axis 2 is a column. Yes, it is just trying to add. But you should remember how it is adding the elements. How it is adding the elements that is represented by using axis 0, axis 1 and axis 2. Axis 0, axis 1 and axis 2. Right? So 0 is a row. Yes. Is a math class only. Yes. Because all these are mathematical operations only. Okay. So what you have to understand in axis 0 is very simple. These are two matrices. These are two matrices and this is a first matrix. Okay. Now along with the axis, and this is a second matrix. This is a second matrix which is having 5, 6, 7 and what here? 8. So what it is happening here in axis 0? This is axis 0, right? In axis 0, what it is doing? It is adding 5 with what? 1. 5 plus 1. 5 plus 1. 5 plus 1 is what here? 6. It is adding 6 plus what? 6 plus 3. 6 plus 3 is what here? 9. 7 plus what here? 2. 7 plus 2 is a 9. And 8 plus 4 is what? 12, like this. This is what here? Axis. Or this is what here? Axis 0. Axis 0. This is axis 0 here. Understood? Axis 0. Then next is what here? Axis. This is a axis 1. What you are doing in axis 1? You are adding. What is this you are adding? 5? 5 with what? 5 plus 6. Yes. Axis 1. What you are doing in axis 1? See here, this is axis 1, right? So sum 3. A axis 1. What is axis 1 you are getting? 4, 6, 12 and what? 14. 4 is nothing but 1 plus 3 is what? 4. And 2 plus 4 is what? 6. 1 plus 3 is a 4. 2 plus 4 is what? 6. Okay, this is which one? Axis 1. And there is one more, which is called as axis 2. What is axis 2 is? 1 plus 2. 1 plus 2. What is 1 plus 2 here? 3. What is axis 1 is? 3 plus 4. What is the 3 plus 4 is? 7. Getting or not? Right. So this is axis 0 and there is an axis 1 and there is an axis 2. If it comes to the sales, right? Now this is a sales. But you can also give multiple accesses. You can also give multiple accesses, right? Yes. You understood? Understood axis 0, axis 1 and axis 2. So axis 0 is what? Column. Axis 1 is what? Row. Axis 2 is what again? Column. Okay, na? Yes. So 2-dimension means it is very easy. Because of it is which dimension? 3-dimension. You have to understand. Okay. So axis 0, axis 1 and axis 2. Axis 0, axis 1 and axis 2. Understood? Again, I am telling you, this is one matrix and this is what? Another matrix. This you call it as axis. This is called as axis 0. What will happen in axis 0? Columns will be added. Now this is 1, 2 and 3, 4. This is 5, 6 and this is what? 7, 8. This is nothing but 5 plus 1. Then 6 plus 2. 7 plus 3. 8 plus 4. This is what here? Axis 0. This is what now? Axis 1. This is axis 1. In axis 1, what it is doing? Row wise. What it is doing? 5 plus 5 plus 5 plus what? 6. 5 plus 6. 5 plus 6. Then next is 7 plus 8. 1 plus 2 and 3 plus. Yes. This is axis what here? 2. Right? So there should not be any confusion here. There should not be any confusion here. That is axis 0, axis 1 and axis 2. Now you can see 4. This is nothing but 1 plus 3 is what? 4. Then 2 plus 4 is what? 6. This is what? Axis 1. Then 5 plus 7 is what? 12. And 6 plus 8 is what? 14. This is axis 1. But in axis 2, 1 plus 2 is what? 3. 3 plus 4 is what? 6. 7. 5 plus 6 is what? 11. 7 plus 8 is what? Yes. That is axis 0, axis 1 and axis. No confusion here. Okay. Yes. Now, what I want is, now if you take this sales, I want the total sales. But actually here, okay, no problem. Now you take this sales here. Sales is there, but you can also give the conditions here. You can also give the condition. You can also give the condition, right? Now what I want is, I want the total sales. Okay, total sales. Total sales means you can apply sum. Okay, for example, I want to, this is first year, right? This is first year. This is the first year. This is the first year, and this is what year? Second year. This is the first year. See, this is the first year, and sorry, this is first year, and this is what year? Second year sales. Now what I want is, I want total sales of first year. How many months? 3 months. First year total sales of, see, how many persons are there? 3 salespersons. How many months sales? 3 months sales. What I want is, I want first year, first person total sales, first year second person total sales, first year third person's what? Total sales. And then second year first person total sales, and second year second person total sales, and second year third person what? Total sales. I want it. Then what will I do? Tell me. Total sales. What? Year person wise, year and person wise. I'll just take total sales 1. Then tell me, what should I write? NP dot. NP dot, what is that? Sum. NP dot sum. What is the name of this? Is sales. Then what I have to do? What I have to do? I have to add all the sales or not? Yes. The sales has to be added. You are adding the elements of this array or not? Yes. Then what will I do? I just write here access. I write access what here? 2. Access 1 or access 2? I write here access 2. I write here what? Access 2. Access 2 I said. Access 2. See here. What is access 2? It is getting 3, 7, 3, 7, 11, 15. Means what it is getting it? 3 means 1 plus 2 is what? 3. 3 plus 4 is what? 7. Here, what I'm doing, I'm adding all these sales. That is nothing but 10,000 plus 20,000 plus what? 30,000. Then you are adding 45,000, 15,000 plus what? 25,000. What is that? Access 2. Understood? Okay, access 2. Access 2. You are adding the values. You are adding the values, right? So I just write here total. Total sales 1. Total sales 1. Spelling. Now if you run this, total sales 1. Now you can see 10,000 plus 20,000 plus 30,000. What is the sales is? 60,000. Then you are saying 45,000 plus 15,000 plus 25,000. What is the sales is? 85,000. 50,000 plus 45,000 plus what? 35,000. What is the sales is? 1,30,000. Understood? Right? Suppose you can also give multiple access. You can also give what? Multiple access. Multiple access. Now here total sales 1. Total sales 1. Then I want, now see, this is total sales person wise or not? Yes. This is a first year sales person wise. This is a first person, and this is a second person, and this is third person. Second year, this is first person, second person, and what? Third person. I want total sales. Okay, I want total sales of each person month wise. Total sales of each person, what? Month wise. Month wise I want it. Month wise I want it. Means I want to add 10,000 plus 45,000 plus 50,000. 10,000 plus 45,000 plus what? 50,000. I want like this. I want like this. Then what do you do it? Now I'm saying total sales. See here, total sales 1. Are you getting or not? Total sales 1, NP dot sum. NP dot sum. and here I am writing sales. Now tell me what is access? Access? Zero, na? Don't say blindly, understand first. Don't say blindly. Zero only. One means one is one, zero, na, what it is. One, zero, na, what it is. Zero, na? Zero, right? Zero. Access? Zero. Zero only, right? So then say total sales 1. Zero, na? 1. Total sales 1. If I say total sales 1, now this is 1 lakh 10,000. Is it correct? 10,000 plus 45,000 plus what? 50,000. Correct? Correct or wrong? How much it is? 1 lakh 10,000, 1 lakh 30,000. Sorry, this is also 1 lakh, which one? 30,000. What you are getting? Access 0. What you are getting here? Which value you are getting? Which value you are getting here? This value, this is output, right? Which one is output? This one is output or this one is output? Yeah, this one. What is the value? 25,000. And then 40,600. This is 69,000. 25,000 you get. What is 25,000? 10,000 plus 15,000. Yes or no? It's correct only. Because you are adding access 0 means 10,000 plus 15,000. 10,000 plus 15,000 is what? 25,000. But it is adding sales of first year and what? Second year. But you want that? No. You want only this sum. You want only this sum, right? You want only this sum. Then what do you do it? Access 0. Access 1. You write access 1. Okay, access 1. Access 1 and what it will do? Access 1. I said access 1. You can see 1 lakh, sorry, 10 lakh, 1 lakh 5,000. 1 lakh 5,000 means 10,000 plus 45,500 plus 50,000. Correct? Yes. So next is 1 lakh, which one? 23,000. You can see 15,000 plus 48,000 plus 60,000. Right? So then you have to use access 1. Access 2, and then next one is what? Access 1. This is what here? Access 2. This is what here? Access 1. This is access. This is what? Access 2. And this is what here? Access 1. Right? Next is, you want anything? Access 0. Access 0 means already we have seen. It is adding sales of both the months. That is first month sales with first month sales. Second month sales with what? Second month sales. That is what here? Access 0. Access 0 means it is adding elements of 2 matrices. It is adding elements of what? 2 matrices. That is called as access 0. Access 1 means, in this case, access 1 is a column. In this case, access 2 is what? Row. That's all. Very simple. So print. Now, if you are writing total sales at 2, so this is a total sales 1, total sales 2, and this is a total sales 3. NumPy dot sum sales access 2, sorry, access 0. It is adding sales or not? Yes. It means first month sales with first month sales. Second month sales with what? Second month sales. That addition is done. Now you can see what is the value is. Sorry, last one. 25,000. 25,000 means 10,000 plus 15,000. 20,000 plus 20,600. Is it doing this operation or not? Yes, that is called what? Access 0. Access 0, access 1, access 2. Clear? Okay, right? Yes. But you can also give multiple accesses. You can give multiple access. Multiple access. Multiple access is defined by using which one? Tuple. But single access you understood? बोलो यार कुछ problem है? I'll tell you again. Yeah, you can write the condition also. Is it clear? अरे बोलो यार. Clear or not? Access 0, access 1, access 2. Access 0, access 1, access 2. Okay. No confusion, right? Okay. Then you can also give multiple, yes, multiple access you can give it. Multiple access you can give it. Yes. How can I give multiple access? I'm writing a total sales. Total sales in the place of total sales. We'll take this one only, right? Because this is easy to what? Understand. Okay, this is easy to understand, right? Okay. Then I'm saying here S1 equal to NP dot. What is the function is? Sum. The function is here sum. Okay. What is the name of the array is? A. A is the name of the array. Now what I'm doing is, so A comma, I'm defining the access. Access equal to, I'm taking access 0. It is defined as a tuples. It is defined as what? Tuples. Access 0 comma, what is that? 1. I've taken access 0 comma 1. Access 0 is nothing but column or row. Actually, you should not think as a row and column. Access 0 means how many matrices? 2 matrices. Access 0 means 2 matrices, and it takes each element of one matrix with another element of another matrix. That you call it as which one? Access 0. That represent 2 matrices. That represent what? 2 matrices. Access 1 represent how many matrices? No. Access 1 represent how many matrices? One matrix. Yes or no? One matrix. And access 2 also represent one matrix. But row and columns. In that matrix only row and column. That is simple. Right? Row and column. In that only row and column. I said here access 0 comma 1. Access 0 comma 1. If you run this, I just write here, I print sum. Now when you print sum, what is the value it is written? 16, and one more is what? 20. The sum is written as 16, and what is that? 20. What is access 0 is? See, access 0 is, now this is a matrix. This is first matrix. What is the elements is? 1, 2, 3, 4. This is another matrix. Okay. What are the elements is? 5, 6, and what is that? 7, 8. 5, 6, 7, 8. Okay. Now just to see here. What it is done? What is the value is here? 16. And here value is 16, and here value is what? 20. The value is here 16, and here the value is what? 20. What it is done? How you get a 16? How you get a 16 here? देखो यहाँ पे आंसर आ गया इधर ही. How you get a 16? Answer is here only. What is this? Access 0. This is access 0. Access 0 na? This is access 0. Okay, access 0. Then what is the sum is? 16. What is the sum is? What is the sum is? 16. What is the sum is? 20. Yes or no? What is the sum now? 16. See here. 1 plus 3 plus 5 plus 7. What is the value? 16. 6 plus 8 plus 1, 2 plus 4. What is the value? 20. So axis 0 and then axis 1 is what here? Column. Axis 1 is what here? Column. Axis 2 is what here? Row. Axis 0. Axis 0 is nothing but matrix. Axis 1 is what? Column wise. Columns. Is it adding all these columns or not? Yes. Then axis 2 means what in this case? Row. Bolo here. Suppose if I am writing like this, yes, a 2 is there. Yes, a 2. No confusion. Sum A comma. What is this here? Axis equal to 0 comma. What is that? 2. 0 comma 2. I print S2. Sum is there. You can see 14. This is a first matrix. Dekho here. This is a matrix 1. Sorry. Time over here. S is a matrix 1 having 1, 2, and this is what? 3, 4. This is another matrix. Answer is there here only. This is what? 5, 6, 7, 8. This is axis 0. This is axis 0 and this is axis what? 2. Axis 2 is there. Axis 2. This is axis 2. What it is doing? 1 plus 2 plus 5 plus 6. What is the value is? 14. Yes or no? Then 3 plus 4 plus 7 plus 8. What is the value? 22. Understood? Bolo here. What is axis 0 represent? Matrix. Axis 1 represent columns. Axis 2 represent rows. Kadam. Remember this. Axis 0 is what? Matrices. Axis 1 is what? Column. Axis 2 is what? Rows. Understood? Bolo here. Okay. Axis 2 is a rows. Axis 1 is a columns. Axis 0 is a matrix. If you write sum of array axis 0, will it add the elements of matrices or not? Yes. If you say axis 1, what it will do? Add the columns. Add all the columns. Axis 2 means it will add all the rows. Khatam. No confusion. फिर और एक मैट्रिक्स आया तो फिर again matrices only. It represent as a matrix. 4D array. If you take 4D array again, it is also having rows and columns. Matrix and matrix. Cluster matrices of matrices. Then that is somewhat difficult, right? Yes. Okay. Now, I think this is clear. Huh? So every class, this will take a lot of time to explain this access. Right. But this access even used with all aggregate functions. All aggregate functions means maximum, minimum, right? So for that also you'll use the same concept. Okay. But anyway, it has took a lot of time, but tomorrow we'll continue. Yes. But today what we learn means access 0 and access 1 only. Right? Okay. Tomorrow we'll continue with more. Right? So we'll stop it here today. आज नोट्स अपलोड नहीं करूंगा मैं. करना है क्या? Yes, sir. Okay. I'll upload the notes after the class. Okay. Yes. Tomorrow we'll continue. Thank you.